In this module, we will be discussing the compressor and clutch assembly. The compressor is the heart of the AC system. It pumps refrigerant and oil throughout the system. It also generates the suction and the discharge pressure. So the compressor is the source of the high side of the system. There's numerous types of compressors in use today. In the truck world, we typically see a rotary swash plate style compressor, typically made by Sandon, made by Valeo, made by Denso. We still see a lot of the old upright design compressors made by TCCI, York, what's left of the old Blissfield company, Tecumseh. Those compressors have not been in new truck production now for many, many years, but we still sell quite a few of them. It's still one of our most popular compressors. On the Sandons, those are typically a 7-cylinder compressor, an SD7. They have small little pistons, connecting rods. Those are connected to that angled plate, so as the compressor turns, it pushes the pistons back and forth, and that's what generates the compression on the refrigerant. The oil. The oil is carried throughout the system. It's suspended within the refrigerant charge. About 5% of the refrigerant charge going around is oil. So operating the compressor with a refrigerant leak will eventually deprive the compressor of oil, resulting in lockup and destruction, causing all the problems that we deal with on a day-to-day basis with compressors. The oil itself, there's several different types of it out there. Back in the R12 days, we used mineral oil. It was a very universal oil. As systems converted from R12 to R134A, we got a new refrigerant, so we started getting new oils. Started out as an ester oil. Ester oil has pretty much gone out of style these days, and all of the compressor manufacturers are recommending and using a PAG oil, polyalkylene glycol. And when you go looking for PAG oil, you'll notice that there's several different types of it out there. There's a PAG 46, a PAG 100, a PAG 150. As time has gone on, that number, the viscosity number, has gone down, where most manufacturers today are recommending and using generally a PAG 46 or a PAG 100, a little lighter weight oil, because even in the wintertime, when you run your defrosters, you're still running your AC compressor, so you need a lighter weight oil that flows well, that will still lubricate that compressor even when it's cold. One thing that you don't want to happen is to mix PAG and ester oils together in the same system. Chemically, they don't bond very well, and they turn into kind of a jello type consistency. And of course, that jello, when it's trying to circulate, doesn't get back to the compressor, doesn't lubricate the compressor well. It gets plugged up in the expansion valves and the receiver dryer, and just causes a lot of problems in the system. So if your customers are looking for ester oil, try to push them over to PAG oil. They'll eliminate a lot of problems simply by using the correct oil in the system. Let's talk about the clutch. The clutch is the round part that you see on the front of the compressor. It's made up of several different components. There's a hub and a pulley. That's the round part you see. Behind that's a big electrical field coil. That's what generates a strong magnetic field to pull the hub and pulley together to engage and start turning the compressor. And of course, it all rides on a bearing. Clutch slippage between the hub and the pulley is a real common cause of clutch failure. When the hub starts to slide or to slip on the pulley, it generates a tremendous amount of heat. And when you start putting 600, 700, 800 degrees worth of heat into these metal components and into the field coil, into the bearing, it creates a lot of problems. You can see how it's burned up that clutch. It's a very common problem out there. When you put that kind of heat into these metal components, it weakens them. When you put that kind of heat into the bearing, the grease runs out of that bearing, so you're running an unlubricated bearing. When you put that kind of heat into the compressor and into the compressor shaft, it weakens the compressor front shaft seal. We always have a lot of problems with front seal leaks. Those are always heat related, overheating. Another thing that the techs want to check is the air gap on the clutch, the air gap between the hub and the pulley. There has to be a small amount of gap in there so that when the compressor is off, the pulley can still freewheel. The belt is still going to turn the pulley and it'll freewheel on that bearing. So there's got to be a little bit of a gap in there. That's typically on a new clutch, that's typically in the 4 to 5 thousandths range. The maximum gap is approximately 16 thousandths of an inch. So the difference between the 5 thousandths and the 16 thousandths is basically the lifespan of the clutch. It's also the movement, the engagement distance of that hub into that pulley. When they get above 16 thousandths, they don't lock together very well. They start to slip on there and causes all the problems. They want to measure that with a feeler gauge. Also want to look for low voltage to the field coil. That is the normal #1 cause of clutch slippage. Liquid refrigerant getting back into the compressor can tend to lock them up and cause clutch slippage. System overpressurization, contamination, oil and grease on the friction surfaces can cause that slippage. But in most cases, it's a voltage issue to the field coil. A quick way to check those is to use your multimeter. You always want battery voltage at the clutch. So on a 12-volt system, you want that 11.5, 12 to 14 volts of battery voltage. The clutch should draw about 4 amps under load, easily measured with an amp clamp. They can also check the field coil resistance. Unplug the connector, flip the multimeter over to ohms, touch the 2 terminals, and they're looking for, call it 2.5, 3 to 4.5 ohms worth of resistance. As the clutches wear, that resistance factor goes up, and when the resistance goes up, the voltage goes down. They can also do a voltage drop test across the entire circuit. They don't ever want to drop more than a volt anywhere in the circuit. If they're dropping more than a volt, that's typically a ground issue, a bad ground, perhaps a bad relay, something like that. If they're dealing with 24-volt systems, again, battery voltage, 24, 26 volts, the clutch will draw about 2 amps under load, and the coil resistance on those should be 14 to 18 ohms worth of resistance.